Sig Figs in calculations. How to correctly show precision when using measured numbers in calculations. When we combine measured numbers, we need to present the answers with the correct number of sig figs to show the appropriate precision. There are two basic types of mathematical operations we use in relatively simple calculations. Addition and subtraction together are one type, an operation and its inverse. And multiplication and division are the other, again, an operation and its inverse. We have different rules for sig figs depending on which type of operation we are using. When doing addition or subtraction, answers are rounded to leave only as many decimal places as the number used in the calculation with the fewest decimal places. When doing multiplication or division, answers are rounded to leave only as many sig figs as the number used in the calculation with the fewest sig figs. You may pause the video to write down these rules if you wish. Adding quantities. Suppose we wanted to add these lengths. 2.63 meters, 0.0652 meters, 7.025 meters, 0.139 meters, and 4.1563 meters. When we add these numbers on the calculator, we get 14.0155 meters. If we look at the uncertain digit in each quantity, the last digit, we see that we have a number of uncertain digits in the answer. Let's place a red dot over the uncertain digit in each number. Whenever we add an uncertain digit with any type of digit, we get an uncertain digit. So the answer has three uncertain digits. The last 5, the other 5, and the 1. However, we are only allowed to have one uncertain digit in the reported answer, so the answer should be rounded to the second decimal place, the fewest decimal places in any of the quantities, to get 14.02 meters. Multiplication and division. Suppose we want to find the area of a field. We measure the size of the field using a meter-long stick with no markings. We find the field is 65.2 meters wide and 123.8 meters long. Remember that with measurements, the last digit is uncertain. To find the area of the field, we multiply the two lengths together. 65.2 meters times 123.8 meters. The calculator gives us 8,071.76 square meters. But since we estimated the last digit of each measurement, we might be off by as much as 0.1 meters on each measurement. That means the field could be as large as 65.3 meters by 123.9 meters, the red area. This gives us an area of 8,090.67 square meters. Or the area could be as small as 65.1 meters by 123.7 meters, the blue area. This gives us an area of 8,052.87 square meters. So we get three values for the area. The smallest estimated value is 8,052.87 square meters, and the largest estimated value is 8,090.67 square meters, with the value from our original numbers as 8,071.76 square meters. Our area is certainly within this range, but how should we express the answer? If we look at our three values, we see that the first two digits of each answer are the same, so they are certain. The rest of the digits are not the same, so they are uncertain. So the uncertainty begins in the third sig fig. Since we can only keep one uncertain digit in the answer, our answer is good to only 3 sig figs. Rather than going through this exercise each time, let's compare this to our original measurements. They were 65.2 meters by 123.8 meters equals 8,071.76 square meters. The first measurement is good to 3 sig figs, and the second is good to 4 sig figs. However, as we have just seen, the answer is good to only 3 sig figs. This is the fewest sig figs of any of the numbers we used in the calculation. So, rather than going through the exercise we just did, we do the calculation and round it off so it shows the same number of sig figs as the number with the fewest sig figs that we used in the calculation. This creates a bit of a problem here, however. The calculator gave us 8,071.76, but the answer is only good to the first 7, 8,070. If we put in the trailing 0 to make it 8,070, we add a sig fig. So, when we have fewer sig figs, 3 in this case, than digits to the left of the decimal point, 4 in this case, we need to write the answer in scientific notation. So the answer is 8.07 times 10 to the third square meters. What about mixed operations, when we're doing both addition and subtraction and multiplication and division? Suppose we wanted to determine the average mileage, miles per gallon, for the series of trips shown in the table. We would need to add the miles traveled and add the gallons used and divide. The totals would be 1,196.7 miles and 75.1 gallons. However, the sum for the miles has the wrong number of places, since entry number 4 is listed only to the nearest mile, not the nearest tenth. So before we divide, we need to round this value off to the nearest whole number, 0 decimal places, like the 213. So we know the number of sig figs we can keep after we divide. So we divide the rounded value for the total miles, 1,197 miles, by the value for the total gallons, 75.1 gallons. When we do, our calculator gives us 15.93874,834 miles per gallon, which must be rounded off to 3 sig figs because of the number of gallons we have, to get 15.9 miles per gallon. So the lesson is this. In order to have the quantities we are using in the right form so we know how to apply the rules, we round off whenever we're required to give an answer to a problem, or when we are changing operations from addition and subtraction to multiplication and division, or from multiplication and division to addition and subtraction.